folks, let's talk about another isomer of C5H10. We did cyclopentane in the previous video, and we're going to go ahead and do 2-pentene to start this video. So let me write that out here, 2-pentene. Now, what you'll want to do with this at first is just kind of get a basic structure onto the paper and then figure it out from there. So what we can see is that we've got some kind of a 5-carbon chain with a double bond. And where is that double bond? Well, it starts at carbon 2 and it ends at carbon 3. So I would go ahead and draw the carbon-carbon double bond first. And we know that this is carbon 2 and this is carbon 3 right here. So working from here, we can back up and say, okay, well, carbon number 1, that's on the end, so that's going to be a CH3. And then we need carbons 4 and 5. And then we can take a look at our structure and say to ourselves, is anybody missing anything? Now, if we look at carbons 2 and 3, we can see that neither of those have an octet. They both have sextets because the single bond is 2, so that's right here. So we've got 2, 4, 6. So the carbon number 2, that's going to need to have a hydrogen, so it has 2, 4, 6, 8 around it. And the same thing's going to happen for carbon number 3. Now, yes, you could have drawn those 2 hydrogens going down, or one of them up and one of them down, but I have the pen, so I drew them up. All right, so that's kind of a general look at 2-pentene. Now, if we wanted to draw the full structural formula, remember we're going to need to draw all of the atoms and all of the bonds. So again, start with your double bond here. And then that's carbon 2 on the left and carbon 3 on the right, so we can go from there. And from the picture above, we can see that we've got a CH3 and an H off of that carbon. So we can go ahead and draw the hydrogen up here and this carbon there, which is carbon number 1, remembering to draw all of the atoms and all of the bonds in. Now, the carbon on the right-hand side of the double bond, that is also bonded to a hydrogen and a carbon, but this carbon right here is bonded to 2 hydrogens, and it's also bonded to another carbon, which is carbon 5, which is right here, and that has 3 hydrogens on it. So that is our full structural formula right there, showing all of the hydrogens and all of the carbons and all of the bonds. Now, what if we wanted to draw the condensed formula for this? Hold on, I need a drink of water. Well, we've already pretty much drawn it above here, but we can condense it down a little bit more. And we can condense it down to CH3, CH, double bond, CH, CH2, CH3. Now notice the only bond that we drew was the double bond. In the condensed structural format, you must draw in double bonds and triple bonds. If you don't draw in a double bond or a triple bond that's there, it's actually not there and it's assumed that it's a single bond. Now the line bond structure for this. We've got 5 carbons. So what you want to do is 1, when your pen hits the paper, that's your first carbon. 1, 2, 3. Oh no, stop it. Okay, 1, 2, 3, 4, 5. And the double bond is between carbons 2 and 3. So you want to go ahead and put that right there. So right here we've got our full structural formula. Here we've got our condensed formula. And here we've got our line bond or our skeletal formula. Or we could call those structures full structural structure, condensed structure, and line bond structure. Now, what you'll notice here is that for the full structural and condensed formulas, we didn't indicate whether they were isomers or not. So if we take a look at this structure and we try to identify whether it's possible for there to be cis trans isomers here, what we'll do is this. We'll look at the carbon on one side of the double bond and see what it's bonded to. And then we'll look at the carbon on the other side of the double bond and see what that's bonded to. Now, if each carbon is bonded to two different things, then we have cis trans isomers that are possible. So looking at the red carbon right there, it's bonded to hydrogen and a methyl group. Are those two things different? Yes, they are. Now, the carbon on the right-hand side, the green carbon right there of the double bond, it is bonded to a hydrogen and an ethyl group. Now, is the hydrogen different from an ethyl group? Yes, it is. So that carbon is bonded to two different things. So we have cis trans isomers possible here. So if we wanted to go ahead and differentiate between the two, when we draw the full structural formula or the condensed formula, we can definitely do that. Let me go ahead and do that with the condensed formula because I've got some room up here. So for the cis, what I'm going to want to do is I'm going to want to have my big groups on the same side of the double bond. And because I drew this structure like I drew it, I'm going to go ahead and stick those down like this because that corresponds more with what I've already drawn right there, okay? And I'm going to put the hydrogens up like this. All right, so that would be your cis-2-pentene. And how would we draw the trans? Well, you would take one side and flip it. So if we go ahead and take this side and flip those around, so you would be breaking the bonds and remaking them, keeping the other side of the double bond exactly the same. What you would get is that, and you can see that your large groups are across the double bond, and so you're going to get trans-2-pentene. So cis-2-pentene and trans-2-pentene are two different molecules with different chemical and physical properties. So they are definitely different molecules. So how would we draw that in line bond format? Well, let me try to squish it in right up here. So for the trans, what you do is you draw the double bond because it's easiest to start there. And remember, you don't want to draw in any of your atoms, and you don't want to draw in carbon-hydrogen bonds. We're going to assume where the carbon atoms are and assume that we know how many hydrogens are on every carbon atom. And then we're going to do this. We're going to go 1, 2 like that, and then we're going to go 1 down like that. And remember, at every elbow and every end of our line bond structures, you have carbons. All right, so for cis, I'll draw that in green. Go ahead and draw your double bond. And what you have is you have your methyl down on that side, and then you have CH2, CH3 like that. And yes, you could flip it over and you could draw it like this. That is the exact same thing. All right, folks. Maybe we can squish in another isomer of C5H10. What about this one? Well, it's already kind of drawn in condensed format a little bit, but can we condense it a little bit more? Yes. Can we draw it in a full structural formula? Of course. So in full structural formula, again, you want to see every atom and every bond. So what you would do with that is this. It's kind of a pain in the butt because it takes up a lot of space and you spend a lot of time drawing things in. There you go on that one. Now, what is that called? Well, how would we number it, first of all? So numbering forwards and backwards on that one is going to give you a double bond at carbon number 2. But if we number forwards, we're going to get a branch on carbon number 2 rather than having the branch on carbon number 3. So we're going to number left to right on that one. So what we have here is we have a 2-methyl, 2-butene. Okay, so we've got a 2-methyl 2-butene on that. So here we've got the full structural formula there. Here we've got a condensed. But can we condense it more? Yes, we can. We can write CH3, C double bond, CH, CH3. Now the thing here is you're going to want to go ahead and put this bond right here, that single bond, and point the CH3 up like that. And so you're indicating that it is not in that chain right there. So if you did this, that's not correct. So you're not going to want to do that there. You could also do CH3, 2, CH3. So there's quite a few different ways that you can do the condensed structural formula. Just be careful of what you're doing there. All right, so does this one have cis trans isomers as possibilities? And the answer is no on that one. And I want you to look over here at the black carbon right there. So we're going to look at each carbon of the double bond individually and look at what it's bonded to. So that black carbon right there, it's bonded to a methyl group and a methyl group. And the rules say that if you have a carbon of a double bond that's bonded to 2 of the same thing, then you don't have cis trans isomers. Now the carbon on the right hand side right there, it is bonded to 2 different things, a hydrogen and a methyl group. So there's a possibility of cis trans isomers if you're just looking at the red carbon. But once you go to look at the black carbon, you see, that's bonded to 2 of the same thing. So no cis trans isomers there. All right, so we did a bunch of versions of condensed. So let's do some line bond on this one. So line bond or skeletal format, whatever you want to call it. All right, so what I would do is I would start with the double bond. Let me do it in black just so you can see it a little bit better. So start with a double bond, and then remember you don't want to draw in any of your carbons, and you don't want to put the single bonds to the hydrogens or draw a hydrogen. So the way you would draw CH3 is just go ahead and put a stick up and a stick down, and now you have drawn this guy and this guy right here. Ignore that hydrogen and then go ahead and draw a stick down like that for that CH3. Now on the right hand side, could you have drawn that single stick up instead of down? This one right here I'm talking about? Absolutely. It's going to be the same structure, no matter how you twist it around. Now, if you mean anything else at the end of the stick other than CH3, you have to draw it in there. So say we had bromine, you would have to draw a bromine there. If you wanted a chlorine, you'd have to put the chlorine there. If you meant a hydrogen, you would have to put a hydrogen there. But remember, in line bond structure, we don't want to draw the hydrogens in there. All right, so let me go ahead and erase those. And there we have the line bond structure for this one over here. Now, are there more isomers for C5H10? Absolutely. There's quite a few of them. Like we could do a cyclobutane with a methyl group off of that. So there's a line bond structure for that. Well, what would the full structural formula look like for that? Well, there's a carbon at each of these corners and at the end there, and then you'd have to fill in the hydrogens. So each of the carbons of the cyclobutane right there is going to have 2 hydrogens on it, except for this one right here, because it's bonded to 3 carbons. So this one, and this one going those ways. So it only needs 1 hydrogen. The carbon on the end right here, that one's gonna be CH3 because it's on the end. So that's how that works. Okay, so how would you draw the condensed formula for that one? Well, you do CH2, and let's point those out of the ring structure there, just to be clear. And then you would put CH3 like that. So that would be the condensed formula. And make sure you draw the ring there. Don't draw something like this, because that's really confusing. We don't know what's going on there. Why does that carbon only have 1 hydrogen when it looks like it should be a straight chain that you're drawing? And why does this carbon on the end only have 2 hydrogens when carbons on the end of straight chains usually have 3 hydrogens? Just, yeah, don't do that. Okay, friends, that is the end of this video, and I hope you have a good evening. Good night.